Good afternoon to you. Mark Sutter with HurricaneTrack.com here with your Hurricane Outlook and discussion for Thursday, the 21st day of June 2018. It is the first day of summer, officially, and did you feel it? It happened. And so now, what is it, just 90-something days until autumn, or 84 days or something like that? I saw somebody tweet that. I'm like, come on, let's enjoy summer first. I love summer myself. So today we have a busy agenda. Not much to talk about in the tropics per se, but my special guest on the Phone a Friend segment that I'm going to start trying to do on Thursday afternoons until things get busy in the tropics. And I'll get to who that is in just a moment. We're going to talk about ENSO, El Nino Southern Oscillation, and the Pacific Meridional Mode, and all things related to that. So let's get rid of me, shall we? And take a look. There's the title screen. Hello, everybody. Welcome again. Here's the blue marble, as I like to call it, and it's pretty today, isn't it? Not a lot of storminess across the tropics, and that's typical for June. No surprises there. Nice little mid-latitude storm system sitting up here over parts of the Midwest, and then a frontal boundary draped, connecting to that deep tropical moisture feed that has been plaguing Texas. It's not locusts that you're plagued with, it's rain down here. Hidalgo County, other areas around that region from McAllen east towards Brownsville and up the coast, Port Lavaca, Port Aransas, Rockport, and then into the Houston area, Beaumont, Port Arthur, and many cities in between inundated with more heavy rain, in some areas more than a foot, and it's just a real bummer, especially on the heels. Even though it's just, almost a year ago, what is it, 8, 9 months, something like that, 10 months, it's still a pain in the butt. So it's going to dry out, believe me. This will abate, and things will get better. You see out here, African dust, very prevalent. You can even see it showing up in the Caribbean Sea as the sun shines upon it. In the Pacific, really not much going on, a little weak disturbance here and here. It's just not a favorable time globally for anything to really develop. So that's good news there. And as such, the tropical weather outlook maps are blank for the most part. There's this one little area in the eastern North Pacific. National Hurricane Center gives it a 30% chance of further development over the next 5 days. There it is right there, well to the south of Central America and Mexico. And if it does develop, it'll head off in this general direction more than likely. And just overall, the pattern is just not conducive, as we're going to be setting up, according to what I have been reading, a very unfavorable pattern in a good deal of the Western Hemisphere, with rising motion setting up over the Central Pacific and sinking air, or subsidence, where the air is sinking and converging instead of rising and spreading out. That'll be prevalent, the sinking air, over the Atlantic Basin and parts of the Eastern Pacific. I read that from Ben Noel Weather, down in New Zealand. Maybe we'll have him on one afternoon. That would be good. What time is it in New Zealand, though? That could be a problem. So this is a neat animation. I showed this a little bit last year, and I saw somebody mention this. I think it was in the YouTube comments. I appreciate it. This is the precipitable water, or TPW, total precipitable water. And you can see that tropical wave. There's another one, and then there's more trying to come off of Africa. But you can also see this blue area. That's your little bit of precipitable water. There's not much there. You can see how it noses its way in, and dry air in the mid-levels especially caps thunderstorm development. It doesn't really allow it to happen, especially in the tropics. And when you have this lack of these oranges in here, and like what you see here, and certainly over here, that's high precipitable water, folks. You don't need me to tell you that. But these are the areas where there's more precipitable water. All out here in the main development region is dry, and so we will not have a repeat of Brett last year, which formed right down here in the deep tropics. Not this time around. It's a different season completely on a lot of levels. And if we look at I just wanted to show you this, not that there's anything really brewing out here. It's still about 60 days too early, roughly, tropical wave there, and then the other one that I showed you farther to the west. But all of this purplish color, that's heat. This is the infrared sensor picking up heat. So it's pink hot instead of red hot. And then you have this energy gathering over the continent. And the models are indicating these tropical waves getting stronger and more robust with time. And so we'll see, they'll probably just end up being seedlings or feed, if you will, for East Pacific action later on. And then you can see on the African dust from the University of Wisconsin site, plenty of it out here. And, is it a little bit more than normal? Maybe, but this time of year, all the way through about mid-August, this is very typical. So no surprises that the hurricane season will probably be pretty sluggish going forward, which is just fine with most people, I am sure. In fact, probably everybody. Nobody wants to be hit by a hurricane, I guess, necessarily. It might be fascinating or interesting or whatever, but you got to be careful what you wish for. I mean, I get it. It's an exciting and an amazing event, but it's beyond most of our capacity to comprehend how much energy is getting released upon us, and sometimes they get out of hand, and you know how it goes. So for the time being, nothing to worry about on any level from the tropics. Now, a radar shot just to kind of show you, much better than yesterday. We're making progress, still some heavier rain towards the Rio Grande Valley, the lower Texas coast area, and just inland. And that will eventually go away, I promise. It'll take another day or so. And you can see part of the trailing front here, some heavier thunderstorms over parts of central Florida, but that's about it. Things are nice and quiet. So today, every Monday and Thursday, the NOAA NESDIS sea surface temperature anomaly chart updates, and this has been my favorite to show year after year for several years. And there's lots of different methodologies and climatological backgrounds, but this one, I try to just stay consistent. And there's a few things that you can see. The warming of the Pacific here, the central Pacific, getting there anyway. Not so much here in the eastern Pacific, the Nino 1-2 area. But notice, too, this is continuing to warm up. And in fact, let's just draw your attention to the main development region in here. And let's go back to June 4th. I mean, come on. That is a pretty stark difference. You don't need me to point that out. It's no stretch of the imagination to see it. June 4th, June 21st. So you would think that by September 1st, if it keeps on at this pace, things will even out. But also, this is a little concerning, the very, very warm southwest Atlantic. I live in Wilmington, North Carolina, and we are about 2 years past the traditional return period of a major hurricane. Roughly every 20 years, we see a major hurricane in southeast North Carolina. The last one was 1996. So do the math. All that warm water there, I tell you what, you just never know. So yeah, we watching this El Nino develop. A lot of the models indicating it later in the year. And if we look at the subsurface, this updated recently as well. And it's interesting, and this will help me segue into our phone a friend guest in just a moment. A lot of warmth here in the eastern part of the Pacific. It's reached the surface. A lot of warmth compared to average, and the subsurface still. But boy, once you get back, beyond, I will call it 150 degrees west longitude, it just drops off. There's just not much there. So this is not a significant El Nino event coming on for 2018. Maybe it'll be for 2019, but that's 2019. Let's bring me up just for a moment. And so this will help me bring up our guest. We're going to phone him in just a moment. And who is it? Let me bring up the Twitter page. We're going to talk to Eric Webb. And he went to NC State, graduated, and now is a grad student at UNC-Charlotte. And he is going to be our phone a friend guest for today via Skype. So let's get rid of me so we can get the camera to work for Skype. And let's dial Mr. Webb and find out more about El Nino Southern Oscillation and other things related to that. Hello, Eric.
Hello. How you doing?
There he is. I just did the introduction, and it's good to have you. I appreciate you joining me. Are you in Charlotte right now? You're in Raleigh.
Yep.
Got a little bit of an echo here. Maybe I can mitigate that on my end. All right. We're going to talk about, I guess, partly one of your favorite subjects. I know you're big into hockey. We'll get to that too. But, you're specializing in tropical meteorology, and you like the whole climate connection thing. And I thought it would be great, since I've seen a lot of wonderful tweets and on Storm 2K as of recently, some great write-ups about El Nino Southern Oscillation, what we call ENSO, and this PMM, and all these different phrases you've been putting out there that, it's very scientific in nature, but it matters for the hurricane season. So I figured you would be great, and not just the hurricane season, but beyond, that you'd be great to talk to about that today.
Yep, absolutely.
So real quick, I introduced you just before I Skyped you, but just a real quick intro from you. I am Eric Webb, and ... Tell us a little bit about yourself.
Yeah, well, I'm a recent graduate from NC State. I have a Bachelor's of Science in Meteorology. I'm going to graduate school this year in UNC-Charlotte, studying climate dynamics. So I'm going to be studying some of the same stuff. So I've tried to really get a really good sense of, and so I really took it on probably about 4 or 5 years ago. I started to really specialize and try to really understand what was going on. This was right before we had the really big El Nino event a few years ago. And since that time, I've really been obsessed with this. And I did my undergraduate research on the El Nino Southern Oscillation and extending that index. So that's available on my website. It's linked to my Twitter page.
Great.
And yeah, I've just been interested ever since. And I also play hockey too, so you'll occasionally see some hockey stuff from me too. And I have a little bit of knowledge about some of the trades and all that stuff, so I'm pretty well versed in that as well.
Very good, very good. So my son goes to NC State. He's going to eventually go to PA school. He started at NC State, which is not typically where one would go for medical or PA school, but anyway, that's a long story. So fellow Wolfpack there with my son. I saw some of your tweets back during the hockey season for State, and that one particular video that went semi-viral. You remember what I'm talking about. We'll get to that before it's over. But so now you're at UNC-Charlotte. That's great. Grad student, too. Boy, I tell you what, hats off to you. That's a lot. Meteorology is tough, right? It is not, like, I don't want to put something else down, but meteorology is, it's kind of like an engineering degree with a whole bunch of math and physics thrown in.
Right. It's something totally different. It's not what you expect when you first go in there.
Right.
You're in the same boat as engineers, except you're not building rockets and
right.
Designing buildings and things like that.
Trying to understand the atmosphere. All right, so speaking of understand the atmosphere, so let's start at the beginning as best we can here. And when we talk about ENSO, or El Nino Southern Oscillation, what is an El Nino at its very basic level?
Very basic level. Well, it was initially described back in the days of Walker and Bliss in the 1920s and 30s as just a warming of the near equatorial waters in the east central Pacific Ocean. It also involves pressure variations, and also there's a bunch of other things like clouds, aerosols, surface winds that are all affected. But at the most basic level, it is really, and the most recognizable form of ENSO is really the warming of the equatorial Pacific, and that's the one I think we have the best measure of.
Gotcha.
Last 150 years or so.
And what's the frequency that we have a warming event on average? How often do we see these warm ENSO events?
Yeah, it can vary anywhere between as little as there can be events back to back. There can be a stretch of a decade or more.
Okay.
It really depends. I was reading through some research earlier today about how ENSO has varied not only over the just the last 150 years, but over the last several thousand years.
Wow.
And extreme variations from anywhere from, we've had El Ninos lasting 4 to 5 years in a row.
Wow. No, thank you.
Right, yeah. And then we've had periods, though, that we've gone 15 or more years without one. So,
without one, wow.
So the observed range of variability, this is part of the reason why I extended, I did that research on extending the ENSO record back to the Civil War, was because our range of variability in the modern record is very, very short. And really, when you provide more and more samples, you extend that, and
Sure.
you're able to see a little bit more variation. And even then, observations are only one realization of infinitely many in a given climate state. So what we observe is not likely the true solution
Sure.
given climate. But yeah, that's basically.
And do we know generally why we get these warming events? What triggers them? Is it just a reaction in the atmosphere that eventually happens, or is there, and certainly there could be this sort of question of what man-made influence is happening out there, and maybe that's a different chapter, so to speak, but why do we get an El Nino at all? Why does it need to exist in the ocean atmosphere state in the first place?
El Nino, well, I guess from a basic premise, the one that everyone really understands is you tend to have breakdowns in easterly trade winds, which then cause the sea surface height, which increases as you go closer and closer to Indonesia, the far western Pacific, to even out, right? It's essentially like a really big bathtub, and it will slosh back every time those winds.
That makes sense, right?
Yeah, but ENSO really is, and when you really get down to it, it is integral to the system. So it's not only forcing the climate, but the climate is a part of the ENSO system. So it's very interesting. There's a lot of very interesting relationships there. And so really some of the work I've been trying to do is trying to understand how these trade wind decelerations, what can sort of force those. One of the things we looked at, and I think I've probably had some tweets on this recently, is how the Atlantic Ocean, can influence ENSO. Right. There are several reasons why I say a colder Atlantic Ocean actually can help boost El Nino events, but it actually doesn't work the other way around. Warm Atlantics actually don't boost La Ninas because the positive feedbacks don't work the other way because there's no
interesting.
Yeah. But what's really interesting is, so essentially the reason why a colder Atlantic like we have this year can actually help an El Nino event along is, for one basic thing, right? If you look at the global tropics, right? If you have one less ocean basin that's warmer than average, it's much easier to get upward motion over a given area of the globe, like the Pacific. But also, when you have a colder Atlantic, you have stronger trade winds. And those easterly trade winds are piling air in towards South America and Central America. And it's that area which experiences a lot of rainfall and upward motion during El Nino events. So it's sort of creating or sort of superimposing itself when you have a cold Atlantic onto ENSO. And there's also some other mechanisms in there like seaching that are really, really complicated. But that's really one of the two real basic ones, is that it reduces the amount of competition globally, motion and ascent. And it sort of superimposes itself onto ENSO. So it's a very interesting topic, and it's something we've really looked into. And it's one of the reasons why, if you look at last year, we had a warm Atlantic, right? We had a really active hurricane season.
Right.
Had an El Nino trying to come on. Same sort of scenario, same exact scenario. But what happened? It faded out because the Atlantic was competing with upward motion, but also the trades were weaker than normal, and so there wasn't as much ascent being forced, at least generally speaking, over that part of the globe. So it definitely does make a lot of sense when you really look at it. So
you also have mentioned this PMM, the Pacific Meridional Mode. There's also, if I understand correctly, an Atlantic version. And for now, let's just focus on that PMM. And I saw you talking about on Twitter for the last several months that the positive PMM, screams certain things, and it looked like it was going to set things into motion. So what is the PMM? And just kind of take us down that road, please.
So the PMM is essentially the Pacific Meridional Mode. That's what it stands for. It deals with the meridional variation of the intertropical convergence zone. I think a lot of people understand what that really is. That's essentially where the trade winds converge. You have convection, right? And flanked on both sides are the Hadley-Cell network. So essentially the PMM deals with the meridional variation of the intertropical convergence zone. But it can also be and it deals with how the trades respond to that. And so what actually happens during the winter, at least in this case, is Rossby waves, mid-latitude waves, break from the extratropics and go towards the tropics.
Gotcha.
And due to that, they impinge onto the Hadley zone, they affect the trade winds in that area. And over time, as more and more of these Rossby waves break, they can sort of instill this memory into the ocean, which persist into the following year. And in this case, we had a really nice pattern where we had these breaking waves constantly going, say, off the Baja of California, and they were weakening the northeasterly trade winds consistently over a long period of time. And that generated a lot of warm water off of the coast of Mexico and all the way extending to Hawaii. And then as we got into the summertime and as that faded away, intertropical convergence zones suddenly lifted north really, really fast. And so that was part of the reason. So I guess another question would be, a lot of people are wondering, man, how does the PMM influence the hurricane season in the East Pacific, So there's several reasons why it actually contributes to more activity there. One, it's often coupled to El Nino. So oftentimes, when you have an El Nino event, the reason you get more activity, at least in the western part of the Eastern Pacific Basin, is because it essentially takes cyclonic vorticity and it vects it, it pushes it from the west central Pacific further to the east.
Okay.
It does that through these westerly wind burst events, which are part of the El Nino too. And think about tropical cyclones. You have a tropical wave. What is the last thing that really happens? We often have south winds, we have easterly winds, we have northerly winds. The last thing that happens is you get those westerly winds on the south side of the circulation. That is the hardest part to do that. Well, when you have a westerly wind burst, right, if you think about it on this
already there.
Much easier, right?
Sure.
Yep, and then of course you have PMM, you have a positive phase. The waters are just warmer in the main developed region of the Pacific.
Gotcha.
So it makes it more unstable. And also, an interesting, contributor is when you have a positive PMM, you have, relatively speaking, you still have warm water in the equatorial Pacific, but if you have warmer water relative to the equatorial Pacific, it actually pushes the ITCZ further north.
Okay.
It's further and further from the equator. You get more Coriolis deflection, and it's much more unstable, and so it's much more favorable to tropical cyclones. And another factor, of course, this goes on the list, is that the PMM warms the waters further and further to the northwest of the East Pacific Basin, so it makes the main development region even larger. So you can accumulate more ACE, essentially.
So it spreads the breeding ground for that particular season potentially out even more. And so maybe areas like Hawaii this year would be perhaps more at risk.
Definitely. And my fear is, as the climate warms, let's say it continues to warm, someday, there will be a time when you don't really need an El Nino or a positive PMM to generate tropical cyclones in that part of the Pacific and legitimately threaten Hawaii each and every year. Someday that's going to happen. It's just the climate is just cold enough at this point in time where it's just not happening. But someday, as that isotherm is at it's about 25 C or so, isotherm continues to move further and further to the north. That main development region will continue to push in that direction. And that's what they see in both climate models and they did in proxy reconstructions as well.
Fascinating stuff. Not all warm ENSO events are the same, and this term this year that seems to be coming up more and more is this Madoki, if I say it correctly. And it's the Japanese meaning the same but different, something like that. And so I guess sort of what is a Madoki El Nino versus a basin-wide, and what effect might that have on the Pacific and the Atlantic hurricane season, since it's not the same El Nino, but it's still an El Nino, the same but different?
Right, yeah. Madoki El Nino is essentially where the warmest waters in the Pacific, in the most basic sense, they're not bucked up against South America, but instead they're further to the dateline. It's also called a bunch of things like Central Pacific El Nino, dateline El Nino, Whirlpool El Nino. But it's really key in that the warmest waters relative to normal over the basin are juxtaposed further and further west, closer to the international date line.
Okay.
What does that do to the hurricane season? Well, at least for the Atlantic's sake, at least especially in the far western parts of NBR, like the Caribbean, now this doesn't mean it's favorable, but Madoki El Niños on average aren't as hostile
Right.
as the Caribbean for tropical cyclones. However, in many cases, they're also can be really favorable for the Pacific.
Sure.
Especially for the Western Pacific. And when you have all those tropical cyclones ongoing
Right.
over that part of the basin, you're releasing a lot of upper-level outflow, and that's being deposited over the Atlantic. So that's effectively acting as an effective El Nino, quote-unquote, not
Sure.
the same as an El Nino, but it has the same mechanism in increasing some of the shear over the Atlantic. And, of course, obviously, it's competing with the Atlantic for upward motion, so then air is going to be sinking there. So it's really
Makes sense.
multiple facets to it. But, yeah, for the Atlantic, Madoki El Ninos usually aren't as bad. However, El Ninos tend to evolve over their lifetime. They're never the same. They're
Right.
kind of like human, right? We start as a baby and we grow up and we change over time.
Sure.
So the same thing with El Ninos. Oftentimes, an El Nino will begin as a basin-wide event.
Okay.
Early in the lifetime, more often than not. And then as it ages, it will slowly be pushed into the Central Pacific, and it'll look more and more like an El Nino. It doesn't happen in every case,
Right.
but on average, you will see that sort of tendency in the record.
So if the tropical Pacific really, like right now, there's no activity anywhere on the globe, and, at what point, if we're not seeing activity in the Pacific, would we start to say, well, that's kind of weird. It's got to happen somewhere, you would think. And, if one basin starts to take over, and I saw the tweet from Ben Knoll today from New Zealand, and I know he's from the Hudson Valley, but it's just interesting to see him tweeting from New Zealand about North American weather. But I think it was the JMA Weeklies or something that tremendous rising motion setting up for July over the Pacific, and the subsequent sinking motion over the Atlantic. So one would presume that the Pacific would be busy in July, but it doesn't have to be. Obviously, just because it can doesn't mean that it will. And like last year, there really wasn't much activity at all in the West Pac. It was, for all intents and purposes, dead.
Yeah.
And so it's almost like, running out the clock. It's like when and if it starts, will it just keep going in the Pacific? Because here we are getting towards the latter part of June, and I can't think of the last typhoon that we talked about.
Yeah, I can't either.
So something is it's not adding up just yet to where all the signs of a classic El Nino are falling into place. I guess, the point is that there's still some room for adjustment, even though we're out of the spring predictability barrier. We still don't know where this is going to land, so to speak, by mid-August for the Atlantic, is what it comes down to. Is that a correct assessment? Like, it's not set in stone that this, and this are going to happen.
Yeah,
There's some things to still watch for, basically.
Yeah, there's still things to watch for. In seasons like this, you'll often see a lot of activity outside the deep tropical Atlantic.
Mm-hmm.
Something that's very different. So we're obviously in a cold AMO. We're starting to enter it. I think people are starting to understand that. Several years ago, this is sort of a tangent here, but I noticed we had really inactive hurricane seasons in the Atlantic that weren't El Nino events.
Right.
We had that in 2013. It was not an El Nino. We had that in 1993.
Right.
And in 1970, 1973. A lot of those occurred right around the time that AMO decided to switch phases from warm to cold or vice versa. So I feel like that was sort of an indication or a big warning flag that, okay, something is clearly going to change, and that's exactly what's happened. It's really since last year was really the big anomaly. On the whole, most of those seasons have been relatively cooler than average in the Atlantic.
True.
But what is different about this versus the last cold AMO era that we had from 1970 to 1994?
Right.
Now we're starting to see this long-term tendency I've noticed for the Western Indian Ocean and Africa for upward motion and ascent. So we've sort of seen this, quote-unquote, this wave number 2 pattern, where essentially you have two areas of corresponding upward and sinking.
Okay.
circulation over the globe. And so what I think is going to happen is we're going to probably have slightly stronger African easterly waves than we saw in that period, despite the fact that the Atlantic isn't as favorable.
Very interesting, right. So you're still going to have those, it's kind of like having some big three-point shooters on your basketball team. You know, the rest of your guards and forwards may not be there, but, man, I got a couple of hot-shot three-point guys, you know, to sort of balance the fact that, and I'm a big Duke fan, but, you know, at least you didn't go to Carolina, or this would have to be the end of the conversation. But, yeah, and I try to relate things, sports and hurricanes in my analogies, but that is an interesting point, Eric, that, okay, the African easterly waves may become more robust, not necessarily counterbalancing the cooler Atlantic and what we call the AMO, or the Atlantic Multi-Decadal Oscillation, to stretch that out. That's what AMO stands for. But those African waves are going to end up somewhere.
Yeah.
They don't just go away.
Yeah, and they just don't go away. And I definitely am of the notion that if you look at the seasonal factors going into this hurricane season for the Eastern Pacific, really this is the best possible recipe that they've ever seen, even better than the active era that we saw in the 80s and the 90s. If you look back in those records.
For the Eastern Pacific.
You see
Wow.
lots of ace and big years. But the advantage now that a year like this is going to have, it's going to have extra essentially from stronger African easterly waves that are getting ingested in the East Pac.
Sure.
There's some studies out there that show that in situ development, so they also get easterly waves that develop off of the Central America high terrain.
Right.
Of South America, and it develops sort of in the intertropical convergence zone locally.
Okay.
But they noticed in simulations where you reduced African easterly wave activity, the number of tropical cyclones actually decreased in the East Pac too. So it does affect them to some extent as well. I feel like this is a really good recipe for them. They have a positive PMM. They have an atmosphere that's leaning towards an El Nino.
Okay.
The Atlantic is going to be shut down, which is another benefactor because then that takes away competition globally. And then they have an active African easterly wave train. I feel like all the recipe, like all the ingredients are really there for the East Pac to go essentially ballistic this year. Of course, there's still a chance it may not happen. But,
right.
It's really a very ideal recipe, relatively speaking.
So it'll be interesting to see if it does come to fruition, are the tracks going to be mostly westward out into the open Pacific towards Hawaii, but we know when they approach Hawaii in today's climate, they usually fall apart when they come in from the east. And then if this just continues on to latter August into September, when we start dropping troughs over western North America, the desert Southwest and certainly the Baja, a la 2014, could come into play again. And I went out west for two of those events and saw that. It was amazing, to have 80-degree dew points in Tucson, Arizona.
Yeah.
So that could be an interesting, as everything changes over time, if you have stronger African easterly waves and maybe a warmer Pacific lasting longer as the Atlantic cools, that your impacts to Baja, Sonora, Mexico, and to the desert southwest of the U.S. could increase over the coming years. That's an interesting possibility, I guess.
It would definitely compensate for, I guess, the increasing lack thereof precip during the winter, because
True.
As the climate warms, we saw back, if you look back in the records, back when the Earth was cooler, those areas saw a lot more precipitation. And if you look in areas, towards like the Miocene,
right,
or when the Earth was much warmer than it is today, a lot of those areas were relatively drier. So they may be drier overall, perhaps.
Right.
But the threat from tropical cyclones might actually increase. You may have more of these very infrequent, but
big spikes. Sure.
Precipitation events there. As far as the tracks this year, usually in these years like this, again with the positive PMM, so now the NDR region is larger, the area for intensification is larger and weakening is smaller. So for areas like Hawaii, this is certainly a kind of year that you just need to be a little bit more vigilant than you normally would be. But years like this typically favor really long-lived tropical cyclones to East Pac, especially when we get into July.
Interesting, especially with the pattern that looks like it's coming with large-scale ascent favored for the Pacific. that'll be interesting to see. So where is ENSO research headed, in your opinion? Like, can you look down the road and say we are going to be focusing on or want to be focusing on this, or is it multiple things, or what? Where are we headed?
It's a lot of things, really. I feel like we're going to get much better at prediction. I feel like slowly but surely, eventually we'll start to look more and more beyond local factors in the Pacific. A lot of earlier research was focused on the influence of the east-driven trade winds, the influence of local forcing from, how the thermocline adjusts due to the trade winds in the Pacific and how it loads and exhausts warm water from the Pacific and how that regulates itself. But really, I think we're going to look beyond that, and I think we're going to start looking to other factors. This could range from anywhere from, variability outside the Pacific, like the Atlantic or the Arctic, or even looking to space, even looking to solar activity, a little bit more. Obviously, it's very elusive to do that.
Right.
But I feel like there's going to be a much, bigger, I guess much more encompassing area of research wherein we're just going to look more and more externally. And I feel like eventually someday we'll get there, and I feel like our predictions will get generally better over time, but they won't be perfect by any means, 30 or 40 years from now.
Right. Yeah, the weather's always going to try to stay one step ahead of us, and we know how that goes. So before I let you go, tell us a little bit about your hockey career at NC State.
My hockey career at NC State, well...
how many meteorologists are also hockey players, too? That's an interesting... I don't know who should be a hockey player, Mark, but I just never thought about it. It's like, wow, he's, playing hockey and doing really well with it, and he's a meteorology student and doing well with that, too. That's kind of hard to do. It's not like, well, I'm a communications major and I'm going to be a basketball player. And nothing wrong with that. I'm just saying meteorology is tough. So tell us about it.
Well, NC State hockey team, I've actually played for about 15 to 20 years.
Wow.
When I was a little kid. So it's essentially like the weather. It really was my first passion.
Okay.
Up until high school, I'd say. I was going to tournaments. I was traveling as far as like California, North Dakota. I was traveling to Canada sometimes to play tournaments.
Sure.
I was really looking into trying to advance my career, going to play juniors, maybe going to play College 1 hockey, in the hopes that I would maybe have a little bit of a chance to make the NHL someday. But then eventually I realized that the chance of me making there are really, really small, but also if, the risk of failure, obviously there's always risk and reward involved in every situation, but I did notice like a lot of my peers that were several years above me had almost every single one of them had came back and went to college, but
right.
I had a reason. They said, well, maybe I'd have to be like further in debt if I did that.
Right.
If you get injured and you don't have a college degree, then what are you going to do?
Exactly.
Serious injury. So that's kind of how I shifted into meteorology. But for NC State hockey, it really wasn't too bad. I mean, weekends were sometimes kind of tough as far as getting schoolwork done, but you had time on the bus, don't tell. It was a really fun time. I enjoyed being with all the guys. I definitely feel like I wasn't as good as I used to be, for sure, just because my passion for hockey just wasn't there like it was anymore. But I tried to play my part whenever way I could. If that meant, punching a guy in the face, to rile, to rev us up, that's you gotta have a wide array of character on a hockey team to really make it successful. You can't just have a bunch of goal scorers, a bunch of playmakers. You gotta have grit. You gotta have guys that are willing to put the puck in the net, guys that are willing to take a hit. You gotta have a wide array. That's really what makes successful teams. So I was like, well, I'm fine with playing this role if that's
right.
If that's what it means.
Well, you did it. That's great. Yeah. And go Wolfpack, right? So, once you're done with graduate school, what do you think you're going to do? You're going to get a PhD? Will it be Dr. Webb someday?
I would definitely like to do that.
Wow.
That's definitely on the list. I honestly don't have a list of schools that I'm really because it's at least two or 3 years down the line, so it's a long ways away. I would definitely want to do research in climate dynamics, staying where I'm at. I really love it, but I honestly would not be opposed to forecasting.
Okay.
And you can probably tell, I just feel like a lot of the research I do, I want to immediately throw it right into the fire.
Yeah, you could apply it.
Right,
Yeah.
Like right away. So with the ENSO stuff, it goes in right away. Like, here's an El Nino coming. Here's the distribution of events since X period of time.
Sure.
I'm going to use this right now at this point in time to help me forecast.
Right.
That's really what a lot of my research is being driven by. So I feel like eventually, I may end up there in some way, shape, or form, and I definitely would love to do that. But that's really what drives a lot of that. And of course, obviously, the snow research and stuff.
Yeah.
I've seen so many failures. And,
Oh, that's right. I've seen some of that on Twitter from you as well.
Yeah,
Your snow expertise and your historical thought process. Anyway, go ahead. I forgot about that.
Yeah, that's another relevant research, and that's all on the website with ENSO and everything like that. I'm going to try to expand it and add some more indices on there and add more products. But yeah, that's the other thing. Like, snow is the most coveted weather phenomena. I currently think in North Carolina. I feel like if you say that on TV more than any other weather, like tornado, you could say tornado, hurricane, whatever. Snow, that causes the most.
Perks the ears up the most. Yep.
Yep, and I feel like it's very important to understand the large-scale historical picture because, again, if you have 30 to 40 years of data from a relevant climate period, that's, what we think of as relevant. We know the climate's warming, we know things are changing, but we only see one realization of many. And so extending the record further and further back allows us to see how it's changing for time and how it may change in the future. One interesting thing that I noticed kind of off the bat is, Raleigh and Greensboro Raleigh often gets shafted, quote unquote.
Right.
But especially Greensboro usually gets, plastered. And this is just something we've noticed, just from living here. But when I looked at the records for the first 40 to 50 years, Greensboro and Raleigh had practically the same amount of snow per season, even when you took into account Greensboro's missing storms. They have a lot of missing data before the 1930s.
Okay.
But even when you accounted for that, Raleigh and Greensboro were pretty much on the same playing field. So there's definitely some, everywhere is not changing the same as far as the current history of North Carolina. Some areas it may actually be increasing.
Interesting.
So it'd be very interesting to see kind of how things have evolved over the past several years, and I'm definitely interested to put it forth. Hopefully, get a nice winter storm, and people become more aware of this research. I definitely would love to again put it right to work.
Well, we know who to get up with in the wintertime because I have, starting in 2014, on a professional level, taken some of the expertise and my equipment, mainly focusing on the strong nor'easters that affect the coastal areas, since they have similar impacts to tropical cyclones with storm surge and high winds, etc. And, we've had a few big snowstorms in the Carolinas, as you're very well aware of, but these really big, intense nor'easters, especially for New England, really captivated me. So starting in 2014, on purpose, I would go up to Cape Cod or New Jersey and put equipment out, either the remote cameras or anemometers and temperature sensors, and then just enjoy it, so to speak. And it's amazing because it's very similar, 70, 80 mile per hour winds sometimes, but it's 25 degrees outside, and instead of horizontal rain, it's horizontal snow. And it's truly fascinating. So you'll be a good resource next winter. We'll probably be talking with you again. I forgot about that. That's right. All right. Well, I appreciate your time. I know that we put this on YouTube and got a good following there on the rest of the social media, Facebook and Twitter. And people really, I started this last week with Dr. Michael Ventris from the Weather Company up in the IBM company up in Boston. And it got a really good reception. So I thought, all right, we'll continue this because, I don't know everything. And I joke. Right, and I joke that when I ever think I know everything, I'm going to retire and just live in a cabin somewhere and, write a book about everything that I know. So until then, it's great to be able to speak with people like you who expand our universe of knowledge to other areas. So, Eric Webb, I appreciate your time today, and we'll definitely be in touch as the winter gets here.
Yep.
All right.
Thank you so much for your time.
Yeah, thanks. Goodbye. See ya. right. So that was Eric Webb. I'm back. Here's his Twitter page. That was great. I really appreciate him doing that. So Weber with 2 B's, Weather. Eric Webb on Twitter. Eric Webb, Weber, Weather. Try to say that. You can see it right there. I really appreciate him taking the time to talk about ENSO and other fascinating topics related to sort of how the ocean and the atmosphere mingle together to give us these interesting results. And sometimes those results can be problematic, as you know. El Nino can have a benign influence as well as a malevolent one at the same time, with different ramifications down the road in the atmosphere, with moisture in some areas, robbing of moisture in others. And so it's all connected, and having Eric on to talk about that was greatly appreciated. So that'll wrap it up. I'll have to figure out somebody. These are just going to get better and better. Who we're going to invite next week. That'll be interesting. I want to keep the streak alive. We've got 2 in the bag, 2 phone a friends, and we'll have to see what we can do from here. All right, that's it from me for today. I am Mark Studd of HurricaneTrack.com. Thanks, as always, for tuning in, and I'll talk to you again tomorrow.